Hey guys, hope you guys are doing well with this whole crazy stuff going on. I think about all of you a lot and hope everything's going okay and you're staying safe and healthy. Um, so, I am going to actually just go through some study notes today, just on section um, 6.1. Okay, and then I'll be doing 6.2 soon and posting it. Now, remember, these video lessons are going to be posted in pages. So look for those under pages, view all pages, okay? Now, I'm still going to be using your um, your study notes that you can print off. I'm just going to be writing them on paper here. So, but I'm still going through the same problems that are on there. So if you want to print those off still and do your notes on there, that's awesome, okay? A couple things. Be sure you are at our open discussion next Tuesday. All right. Ours is at the same time as our class time. So, gosh, you guys, I can't remember when our class time was. I think it was at, let's see, 1:30. Okay. So, and this should be in that updated syllabus that I sent out to you. So I apologize for my voice. I've been trying to do these study lessons for 5 classes, and so it's a little bit crazy. Um, I'm going to be posting by tomorrow, which is Wednesday. I will post a lesson assignment for you to do on 6.1 and 6.2, and you'll have some time to do that. So there's some flexibility. I gave you some time to get the work done, but don't forget you still need to stay on top of your your math lab section work as well, okay? Also, a few of you still don't have test scores in, and that's because they shut down and I couldn't get in. So, but they did, just got an email, they sent those to me, so I should be getting them. If you don't have a grade, I will get those graded as soon as I get them and get them in the grade book for you, okay? Because we've lost a week of class time, we're going to cut short some of the things that we're doing. It's not anything that's going to affect you going into your next 1380 class. You all should be fine with that. Definitely be prepared. So I don't want you to worry that you're going to be missing out on any material that you're going to need for 1380, okay? All right, so I'll get through this kind of quick, just so you don't have to sit and listen to me talk, because I'm sure that's not very exciting. And so let's talk about, first of all, rational expressions, which is 6.1. All right. So a rational expression is an expression of the form P over Q when I have a polynomial on the top and a polynomial on the bottom, which that means I have an x variable in the numerator and an x variable in the denominator. And so this is just saying that Q cannot equal 0, right? Okay, because then it would be undefined, right? So when we look at something that says evaluate, all that means is we substitute in this number for x. So if we want to evaluate for a, all we're going to do is put in a 2 for our x value and then simplify it. So 3 times 2 is 6. 6 plus 6 is 12. 4 minus 6 is a negative 2. And so simplify that down. 12 divided by negative 2 is a negative 6. All right, for b, we're going to substitute in a negative 3. So again, evaluating, we just put a negative 3 in for x. So 3 times a negative 3 is a negative 9, plus 6 is a negative 3. A negative 6 minus 6 is a negative 12. Now let's simplify that down. And so that's a negative divided by negative is going to be a positive. And if I divide a 3 out of each of these, that reduces down to 1/4. Okay, so that's evaluating expression. So you have to kind of bear with me on this dot cam. It's kind of new to me here. So, all right, so let's then talk about when something is undefined. And in short, to determine if something is undefined, you set the denominator equal to 0. And does that make sense? Because if I set it equal to 0 and I find what number would make that 0, okay, then that's where it would be undefined. And undefined means your denominator is 0. So if I have something like this, okay, all I'm going to do is take that denominator, I'm going to set it equal to 0. And I'm just going to solve that. So let's subtract 2 on both sides. Okay, and then divide by that coefficient. So my answer here is x is equal to a negative 2/3. So what that is saying is if x were a negative 2/3, this would be undefined. Because if I take 3 times this, that's a negative 2. Negative 2 plus 2 is 0. So if I put this in for x here, it's going to make this 0, which would make that fraction undefined. Okay, so that's all that's asking for. Now sometimes, here's another example. All right, so in this particular one, if we're going to set this equal to 0, okay, what do you have to do there? See, this is hard for me because I have all these questions for it and I just have to answer my own questions. So we're going to set it equal to 0, and the only way I can do that is by factoring. So we have to factor this out. Now remember, if this is a 1, that's kind of nice because I just split the m's, right? Not sure what kind of m that is that I drew, but all right, so we want what are factors of 6 that I could get a negative 5? Well, keep in mind, if I have 6, I have 1 and 6, and I have 2 and 3, and both of those would give me 5, right? So if I use 6 and 1, and I have a negative 6 and a positive 1 to get a negative 5, that works. However, if I multiply these together, that gives me a negative 6. So it really doesn't work. So that's how I know that I need 3 and 2 to get a negative 5, because when I multiply those, it gives me a positive 6, right? Which is what I need. So I have a negative 3, negative 2 in any order. Now I'm not done because it says set equal to 0. So that means we have to take each of those and set those equal to 0. So we add 3 here and we add 2 here. Okay, so it would be undefined if I put a 2 in here or if I put a 3 in here. Neither of those would work. So that's where it's undefined, when m is 3 and when m is equal to 2. Okay. Now you have another one on your study guide that has an r squared plus 1 in the denominator. We're not doing that problem because it comes out to be a complex number in I, and we haven't talked about that. So just cross that problem off. Okay. Sorry if this is kind of noisy on the microphone. Maybe I should move it on this side. All right, so let's take a look at the fundamental property of rational expressions. All the fundamental property is, you guys, is just simplifying down a fraction. Okay, now those fractions will eventually have variables in them. But for example, if I have 30 over 72, I'm just going to simplify that. So what is something that goes into both of these? Well, I can divide them both by 3. I could also divide them both by 2. Oops, sorry. There we go. I can divide them both by 3. You could divide them by 2. You just have to figure out a common number that they have in common that I can take out of there. So if I do this, we have 10, and then 72 divided by 3 is 24. I haven't done math for a while, guys. All right, so now I have to keep breaking it down if I can. So I can still take 2 out of each of these. And so that's just simplifying down a fraction. All right, now let's look at another example here. Let's say we have 14. These are from your study guide. All right, so recognize I can take a 2 out of both of these, right? Or I could just say 2 goes into 14 7 times. That's fine too. I don't have to show the 1 on the bottom. Now remember here, I have a larger, I have 3 k's here and I have 2 here. So that means if I divide 2 out of both of them, I'm going to have 1 left on the bottom. So 7 over k, right? Because I have 3 here and I have 2 here. So I take 2 out here, 2 out here. I still have 1 left. All right. So let me just get rid of, I'm just going to move this out of the way. Okay, so let's look at what happens when we are trying to write these in lowest terms. Okay, writing a rational expression in lowest terms. So given something like this, the first thing you always want to look at is to see if you have a greatest common factor. So greatest common factor here is on the top only. These both have a 3 in common. So I can factor out a 3. So 3x divided by 3 is x. Negative 12 divided by 3 is a negative 4. So all I did is factor a 3 out of each of those. Now on the bottom, what do these have in common? Well, I can take out a 5. That's the biggest, greatest common factor that I can think of that they have in common. So let's factor a 5 out. Well, 5x divided by 5, negative 20 divided by 5. And what we're hoping for is that we do end up with these factors that are the same, so we can just cancel those out. And so in lowest terms, this rational expression can be written as 3/5. All right, so let's take a look at another example here. So 2y squared. All right, so let's say we're there. Let's look at the top. Oh, you know what? We need to change this number right here. This is an error in that. Let me think. We need to make this a 32. So this was originally an 8, and it's incorrect. Let's change it to a 32, or the problem's not going to work out very well. Okay. So let's take out a 2. If I take out a 2 here, I have a y squared. And then this negative 32 divided by 2 is 16. Now, what can I take out here? Well, they have a 2 in common. So 2y divided by 2 and 4 divided by 2. Now, I don't see anything there aside from, I could cancel those out. Okay. What you need to be really careful of is I cannot cancel these 2's out here until I've factored them out. Because that's going to throw your entire problem off. If I cancel out these 2's right here, it's not going to end up with the right answer. So you can't take out, remember, part of a term, but if I factor them out and I have the same number, then I can cancel those. So this will go a little bit further, because if you recognize this is a difference of squares. So I can actually, oh, you know what, you guys? This should be an 8. I apologize. Sorry about that. I apologize. Go ahead and leave it as it is. So if I take negative 8 divided by 2, we have a negative 4. My fault. Sorry about that. There's an error on my key over here. So here, this is a difference of squares, right? So I can still break that down. Remember, this difference of squares, this has to be a perfect square and this has to be a subtraction. And then on the bottom, I have a y plus 2 that's left. So from there, these will cancel out and I'm left with a y minus 2. I simplify that. Okay. All right, let's do one more. So this again is from your study guide. So here, all right, so let's take a look at this one. So on the now notice we have 3 terms, so we look for greatest common factor. Let's just look at the top. There's not a greatest common factor. However, I'm going to be able to then, because I have 3 terms and this is a 1, I'm going to be able to just factor this out. So this is why the factoring is so important, because we use it so much when we're dealing with you know, rational expressions, and you'll just see how often we use the factoring. It's really important. So keep working on it. If you're struggling with it, keep trying, okay? So let's split the m's. What multiplies to equal 8 can I get 2? Well, how about 4 and 2, right? So we have 8, we have 4 and 2, so we have 4 and 2, and we need a positive 2. So what would the signs be? Positive 4 and a negative 2. So one's going to be a positive 4, and one's going to be a negative 2. All right, so let's go to the denominator. Well, look here, these do not have a greatest common factor. They don't have anything in common aside from 1. So, and this is larger than 1, so let's go ahead and use the AC method. So I'm going to take 2 times a -6. I'm just going to do that work. I'm going to do that work down below here, okay? So we have a -12. I told you don't really have to show that negative, but now what multiply, I need it to be a -1. So can you see where I would maybe use a -4 and a +3? Okay, that gives me, so I'm going to replace this -1 with this -4 and a 3. So I'm going to bring the 2m squared down, and then in any order, -4, whatever that is, m, plus 3m. Notice these would equal that. I'm just replacing them, and then bring down the last term. It's been a while since we've done some of this factoring. So here, now we have the grouping method because we have 4 terms. So now let's group it. What can I take out that's a greatest common factor over here? I can factor out they have a 2 in common and they have an m. So 2m squared divided by 2m. Okay. -4m divided by 2m. It's -2. Okay, so bring down this sign. Now what do these have in common? Well, they have a 3. So let's factor out that greatest common factor of 3. 3m divided by 3. -6 divided by 3. Now we want these to be the same, otherwise it's not factorable. So now looking here, what do these have in common? Well, we have an m minus 2. So if I take an m minus 2 out of this, I'm left with a 2m. And if I factor an m minus 2 out of here, we have a plus 3. So that's what we're going to bring up here. That's what this denominator is factored. So what do I have in common? Well, I can take out an m minus 2. Those factors are in common. Now I cannot cancel out this 2 and this 4, right? Because this is part of this factor. So what I'm left with then for an answer is m plus 4 over 2m plus 3. And that's your reduced fraction. So this would be the answer that we're looking for. Okay. All right. So let's just do a couple more examples of writing in lowest terms. So this is kind of a different example. Maybe I should label these so at least you know they're different. Does that help a little bit? All right, so let's take a look at this one. So here we have x minus y over y minus x. Okay, so what I want you to do is I want you to rewrite those so both of them have the x value written first. So here we have x minus y. And then down here, if I wrote this first, I'd have a -x plus y. Okay. So if I continue on with that, and this is something you won't see now, but once you see it, you hopefully will be able to recognize it from here on out. This I'm going to take a -1 out of. So if I factor out a -1, right? So it's really changing your signs. -x divided by -1 is a positive x. Positive y divided by -1 is just going to give me a -y. So it's really just changing the signs when I take that negative out of there. But look what happens here. Now I have a factor that I can cancel out. So when I cancel these out, what I'm really doing is saying, well, x minus y goes into here one time, x minus y goes into here one time. So you have to remember that you have to leave that -1 on the top. You can't have a 0 if you cancel it out. It's like 5 divided by 5 is 1, right? So that's what we did. X minus y, we divided it by x minus y. And then on the bottom, we have a -1. So what that does simplify down to is a -1. So really, you could recognize and just see this and go, oh, that's a -1. Okay, but you have to be kind of careful because maybe I'll show you another example here in a minute. But so here, let's look at this one. Okay, so notice on this one compared to this one that it already has the x's written first. And they're not the same. If I took a -1 out of one of these, it's going to change the sign here. So this is actually already simplified. I can't do anything more for that. Okay, so that one is simplified. Sorry, I'm getting kind of rotating it here. All right, so let's, how about this one? Okay, again, the m's are not both written first, so let's put the m's written first. So up here would be a negative m, and it's positive 2, right? Over m minus 2. We don't ever want this to be a leading negative number, so let's go ahead and take out a negative 1, and that's going to change that sign. Negative m divided by negative 1 is a positive m. 2 divided by negative 1 is a negative 2. So what I see there is that I'm left with a negative 1. Very similar to the problem in D. All right, lastly, let's look at this one for G. So, I would probably go ahead and start this problem by just writing my x values first. Okay. Now, let's look at the top, difference of squares. There's only 2 terms, so I can't factor it like I could up here when I have 3 terms, right, like this one. But I have 2 terms, and these are both perfect squares. If they were not perfect squares, I couldn't factor them. If that was a 4x squared minus 10, I wouldn't be able to do it, all right? So, but I can, and this is going to be a 2x, and this is going to be a 2x. And then the square root of 9 is 3. One's positive and one's negative. Okay. All right, that's the difference of squares. Now down here, let's look and see. So we don't ever want this leading term to be negative. So we're going to take a negative out for sure. Do they have anything else in common, okay, besides a 1? They do. They have a greatest common factor of 2. They have a number in common. So let's take that 2 out also. Because if I don't take out a greatest common factor, it's not going to be simplified at the end. So I won't be able to see that I can cancel these factors out, okay? So let's take out a negative 2. So negative 4x divided by negative 2 is a positive 2x. And 6 divided by negative 2 is a negative 3. Well, what's nice is now I can simplify this down because these will cancel out. Again, don't cancel these because this is part of this whole factor, okay? Has to be exactly the same. So the answer is 2x plus 3 over negative 2. And that's perfect. You can leave the negative there. You can move the negative here if you wanted to, but just leave it as it is. That's great. Okay? So that, my friends, is section 6.1. So I'm going to work a little bit later on 6.2, and I will get these posted for you as soon as I have them both done. All right, and then I'll get you an assignment posted in your all pages that you can work on as well. All right, guys, have a good one. See you later.